Hello, and welcome to our lightning talk. In this video, we will introduce you to both the problem posed to our team at the beginning of MSD and the solution we found throughout MSD. But first, a quick introduction. We are Project Team 19102, a multidisciplinary senior design team in the Kate Gleason College of Engineering. Our team is made up of computer engineers John, Tyler, and Max, and electrical engineers Rihanna and Allison. Our project is sponsored by L3 Harris, and we worked with Dr. Leszewski, an RIT professor, as our client. The proposed project was to detect, identify, and classify live radio frequency data and identify when jamming occurs. This would alert a user when their channel is being interfered with and allow them to move to a different channel. After meetings with our client, our project narrowed to focus on the tracking of a specified signal across channels. Our stakeholders are interested in a reliable method of classifying live radio frequency data. The major points of consideration: producing a live spectrum, using machine learning classification on signal characteristics, and tracking across channels.
One of the considerations was the creation of a live spectrum. This involves capturing and visualizing real-time radio frequency data to monitor and analyze signal activity. Another aspect is the use of machine learning to classify signal characteristics. Finally, tracking the specified signal across different channels is essential. Narrowing the project scope was a significant challenge. The original scope of classifying jamming was very broad and difficult to implement, as there are many different types of jamming, and creating a test environment was not feasible. The team then moved towards classifying a variety of signals by modulation type. This idea required numerous transmitters capable of producing various modulation signals and similar frequencies, which presented a new series of challenges and drifted from the channel classification of the original proposal.
After meeting with our client and subject matter experts, we found a new approach that meets the customer requirements and is feasible for the transmitter and frequencies available to us. We moved forward with tracking two signals defined by a difference in power level. The signals were transmitted in channel 1 at 452.3 megahertz or channel 2 at 457.3 megahertz. Based on signal characteristics like gain, the SVM model identifies the desired higher power signal if it's present in either channel.
So in our approach, RF data is collected through IQ data, which is a measurement of the signal's magnitude and phase through a software-defined radio, which is then connected to our system on module, which is a computer called the core board. The data is then processed to produce a live frequency spectrum of the output, and then sends it through a support vector machine learning model to determine whether we're receiving a desired classified signal on either channel 1 or channel 2. The classification is then displayed live on the spectrum for both spectrums. And overall, the whole system is powered by a battery and enclosed in a protective case, which makes it portable and durable.
The device can operate for over 2 hours at a time and adequately displays the frequency spectrum in near real time. Classification results at the top right corner of both spectrums are displayed. The training model has a 100% accuracy on test data and very clearly divides the two input signals into two classes, where the desired signal is indicated by the blue markers. The graphic on the right demonstrates that the model works well on live data and correctly identifies the signal of interest when present.
We'd like to thank our subject matter experts, Carlos Barrios and Mark Indivina, for their advice and support, as well as our guides, Tiona McCauley and Donald Popal, for assisting us throughout the project. Finally, our client, Dr. Sergey Leszewski, for his time and feedback. We would also like to thank Mike Vaseo and Glenn Geyer for their assistance in acquiring RF transmitters.